Hey, Daryl.
Hey, Todd, good to see you.
Yeah,
You look,
likewise.
you look warm and comfortable there.
It's not bad. I say it's not bad. What's it like there?
I rode my bike in today and it was about -3, I think. So,
Well, there are a couple of issues I sense with that one.
yeah, we can get into that, right? A lot, it's probably multiple issues that we could talk about.
How are you doing other than the weather?
Good, good. Semester just restarted back up, so it's good to see all the students back in and getting things going again. So,
That's good.
yeah.
A high demand major, it sounds like.
We have a lot of students right now, so we'll
Yeah,
go through some of the numbers as well, and just part of this presentation at the beginning.
that's great. I'm going to have to probably jump off halfway through just to let you know. I'm trying not
Okay.
to, but I might have to.
Well, thanks for joining us, Todd.
Yeah.
All right. Ready? Okay. It's my pleasure to welcome all of you to this mechanical engineering town hall. This is our first time doing an event like this, so it'd be great to get your feedback afterwards to know how it goes, how we can do these better, and whether we should continue these on a regular basis. There are a few others here from UW College of Engineering that I'm not going to have them introduce. I think they have this videos on right now. So Paul Wilson, who is chair of engineering physics, which was the previous home of engineering mechanics, which just recently moved to mechanical engineering. So he'll be available for questions afterwards. We also have Frank Pfefferkorn, who's the associate chair for graduate studies in the Department of Mechanical Engineering, and Kurt Bronkhorst, who just moved to the Department of Mechanical Engineering. He's in the engineering mechanics program. Mike Zinn, who's the associate chair for undergraduate studies. And Xiaoping Chen is also on here. He's our associate chair for research in the Department of Mechanical Engineering. So what we had planned today is I have a few slides to present to you to just give you a few updates on things that are happening in the department currently. And then, whoops, I'm at the end of the presentation. Get a quick preview there in reverse order. So hopefully everyone can see the slides at this point. So the agenda, what we're going to go through is some updates on the undergraduate program, what is going on with faculty hiring and new research activities. We'll briefly review some of the current plans that are undergoing for the new College of Engineering building, and then leave enough time for some question and answer, hopefully answers. And we got a few questions up front, and I think we'll probably start with those. So undergraduate programs, the message here is we are popular. Mechanical engineering is a very high demand major at this point. We've grown, our undergrad student numbers have grown 40% over the last 5 years. So now we have the nice challenge of figuring out how we're going to scale up our classes and labs to accommodate the number of students we have. Just to give you a perspective, traditionally we graduate around 200 students a year. This fall, we admitted about 350 who came into the Department of Mechanical Engineering intending to major in mechanical engineering. So it's quite an increase in terms of the number of students that we are educating. But the great thing is they're getting jobs. They're really highly qualified students. So we're happy to have them, and it's a good challenge to take on. As far as the diversity of the ME undergraduate population, this plot here basically shows that the percentage of females has remained relatively constant. It's around 14 to 15%. So that hasn't increased. We'd like to see that increase. But the good news is the number of total number of female undergraduates in mechanical engineering has gone up with the population of mechanical engineering. So it's up about 50 students in 5 years, female students. I thought I'd put this in a little bit for bragging rights for all of you. So you are a graduate of the 4th largest undergraduate major at UW-Madison at this point. So we're trailing computer science, psychology, and business. And you can see we just incremented past biology actually in the past year in terms of the size of our program. And we are also the largest undergraduate program in the College of Engineering by a considerable amount in terms of the number of students. The one thing I would point out here is that this plot also shows engineering mechanics, which has about 200 students, and about half of them would be in the aerospace engineering option. So with the move of engineering mechanics into mechanical engineering, our total undergraduate population now is above 1,400 students, or it will be shortly once the programs are fully moved. A couple of exciting things that are going on in our undergraduate curriculum. One is we're going to replace the traditional ECE 376 circuits course with a mechatronics course. This is a change that was advocated for very strongly by our industrial advisory board. That reflects kind of what's happening in industry with the fusing of electronics and mechanical systems. So we have planned a 4-credit class. So it'll be 3 credits a lecture and a 3-credit and a 3-hour-a-week hands-on laboratory activity lab in which they'll go through analog electronics, digital electronics, microcontrollers, actuators and sensors, communications, and feedback control. So shown here is just some of the hardware that Eric Oberstar has prototyped to get this up and going. And the plan is to phase this in starting in the fall of next year. So we're really excited that this is going to be in place for our students going forward. The other curriculum update that I included is the size and I guess breadth of our senior design. So a few years ago, we switched to a 2-semester capstone design sequence. So students do a 2-semester project where at the end of that, they expect to have physical prototypes. Mike Cheadle is an assistant teaching professor in mechanical engineering. He's the senior design coordinator. To give you a perspective, he has 64 teams this year involving 255 students. And we have they're all client-based projects. So he has a number of companies that are sponsoring projects, some community service projects, some research labs. We still have some competition teams like the car teams and some entrepreneurial activities that make that up. We have a nice design expo at the end of the year where the students get to show off their projects and some judging and we award some prizes. One shout out here is if you ever want to re-engage with the Department of Mechanical Engineering, work with some students, we're always looking for clients for our senior design teams. So please feel free to reach out to Mike Cheadle or myself if you are interested in that opportunity. And basically what we're looking for is a good project idea and some of your time that you're willing to commit to, once a month or so where you can touch base with the students, figure out where they are at and provide them some feedback just to make sure they stay on path. And then one additional note is just, we are working very hard at improving climate and diversity throughout the College of Engineering and in mechanical engineering. And we got a number of initiatives going that involve K-12 activities, trying to hire more diverse faculty, and recruiting undergraduate students. So we have a number of scholarship activities that are targeted at individuals from underrepresented groups. We're proud to announce that last year we gave out nearly $790,000 in scholarships to mechanical engineering students. And that is about 300,000 higher than we'd ever done before. And so, and it's in large part thanks to the alumni and the generous donors that have supported us and provided us the resources that we can give back to support current students in the program. All right, a couple updates on faculty and research activities. We've been hiring with all the growth in the student numbers. We've needed to grow our department. And there's also some very strategic opportunities to expand in some research areas. Some of our targeted areas include energy systems and energy storage and computational and data-driven engineering. The 5 faculty who started in the fall are all fall in these 2 areas. We're really excited that Eric Kaziak here is going to start a battery research lab. He does battery materials, interface mechanics type research for looking at alternative materials for batteries. Allison Mabi moved here from the National Renewable Energy Lab, and she's very interested in thermal energy storage systems for buildings. And then Eric Turbo is a partial hire in mechanical engineering, also in electrical engineering. He's interested in nanoscale thermal systems, and particularly solar energy conversion. And then in the computational and data-driven engineering space, we hired Ying Li, who was a very successful faculty member at the University of Connecticut, who does computational or data-driven approaches to designing new polymers for extreme environments. And then Jinlong Wu, who's an expert in machine learning and computational fluid dynamics. And that's an incredibly important area for us as data-driven engineering becomes more popular. We also have 2 additional faculty starting this semester right now in January. So Luca works in fuel cells and in hydrogen, and Xiaobing Zhang works with ligid robots, so walking robots, both bipeds and quadrupeds. And he's just getting that system up and going. James Pickle will be joining us in the fall of 23. And he does a range of things from micro batteries to soft robotics to self-healing metals. And then finally, Jennifer Detler, who just graduated with her PhD in December from our department, is starting as a teaching professor, and she's going to teach in a number of different areas for us. So we're super excited about all that hiring activity. What that basically means at the end of the day is in 4 years, we've grown our faculty by 40%, right? So if you think back, I showed you our student numbers grew about 50% in 5 years. We are building up our faculty to maintain this student to faculty ratio that we have, so that we can both sustain these high quality research programs and provide a quality undergraduate education. 2 notes I want to make here. One is really great news, and that is you see almost equal blue, orange, and gray. So that's assistant, associate, and full professors. And basically what that means is we're not top heavy. We have a nice equal distribution of new faculty coming on and older faculty like myself, who are still hanging around, I guess, which is healthy for the department. The second big note here is this is a really significant investment, all of this hiring activity, because each one of these faculty that we bring in, we give them a startup package to start their lab. We remodel a lab space for them. So it's a big investment on our department, on the Department of Mechanical Engineering, and also on the College of Engineering and campus to do this. So we really appreciate the support that we get. I will mention that the department, we rely a lot on gift funds to support these new faculty hires. So gifts from alumni have helped us considerably in this activity. All right, a couple notes on the move of the engineering mechanics faculty and engineering mechanics programs into the ME department. So the background on this is this recent growth in the ME department resulted in a situation where we were hiring some faculty who specialize in engineering mechanics as a field, a research field, right? And traditionally, engineering mechanics is in the Department of Engineering Physics. And engineering mechanics underlies a lot of what we do in mechanical engineering. There are a lot of exciting applications of mechanics nowadays. So, for example, Christian Frank uses engineering mechanics to study traumatic brain injury. Ying Li is using engineering mechanics to study design of new polymers using data-driven approaches. So it's very fundamental to what we do, but that resulted in us having mechanics expertise distributed across both the ME and engineering physics department. And then that introduces some challenges, both in instructional and strategic planning of mechanics activities. One easy example to understand is when we're requesting new faculty hires, mechanical engineering would be asking the dean for a position to hire an engineering mechanics person, and so would the engineering physics department. So in a sense, then we're competing with one another in the same space, which is not as strategic as it could be. So the plan is to unite the mechanics community in one administrative home. And if you look across the country, most engineering mechanics programs at this point exist within a mechanical engineering department. So our peers have largely gone in this direction. So it made sense that if we're going to put them in one home, that we'd put them in mechanical engineering. So going forward, what we'd like to do is develop and articulate a shared vision and strategy for supporting our collective research portfolio of the faculty across the two departments and the affiliated instructional expertise in mechanics. So all the engineering mechanics faculty are moving into mechanical engineering, joining our mechanics faculty, and are going to work on a shared vision. And we also have a couple of additional hires that we'll do in the mechanics space, but we'll do it collectively in a strategic way, working together. The plan also involves us sustaining the engineering mechanics degree program. As I mentioned before, it has about 200 students in it. It remains a popular major, in particular the aerospace engineering option. So we're fully going to continue to support that. And then the other part of the plan is there are some advantages that allow us to streamline some of our instructional programs. So we have a larger pool of faculty who can teach mechanics courses that serve ME and EP and actually serve other departments in the College of Engineering as well who take these classes. And we can work together more collaboratively on distinct offerings that characterize the uniqueness of the ME and the EMA degree programs. So we think this is beneficial for both parties, and we're super excited about what this means going forward. So this slide just shows you who the engineering mechanics faculty are and the programs that we are moving over. So there are 8 faculty in total. I won't go through all of them, but you can see their pictures here. But they do things related to fluid dynamics, both computational and experimental. Solid mechanics is also both computational and experimental as well, is the primary areas, and then an array of applications of those fundamental disciplines. The degree programs, so the faculty have actually just recently moved over, so they're now fully members of the Department of Mechanical Engineering. The degree programs are lagging mostly because there's a lot of hoops to jump through at the campus level to officially move a degree program from one department to another, and we're just going through that process right now. But none of that affects students who can continue to take classes and progress towards their degrees as is. So the degree programs moving over include the bachelor's, master's degree, and the PhD programs, all in engineering mechanics. So in total, it's about, as I mentioned before, about 200 undergraduate students, and this affects about 20 graduate students who will, and in the fall, have their home department be the Department of Mechanical Engineering, though their degree program is in engineering mechanics. So what does that do to our tenure track faculty count? That brings us up to 48, so almost up to 50. So that's about 63% higher in 5 years. That's what we'll be in the fall. Actually, we are there currently. And that increase then represents the move of EMA and our recent hiring that we did as well. We're not done. We're still going. We're recruiting for 3 people this year, 2 in robotics and autonomous systems. And then there's a dual career candidate that we're interviewing as well that we might be able to bring on. And then we have plans to search for 5 additional faculty next year in polymers, energy systems, autonomous experimentation, and then these 2 in mechanics. And the exact areas of mechanics that we search are now being worked on by the joint mechanics faculty between what was the engineering mechanics program in engineering physics and our mechanics faculty here. They're working together on the strategic plan of where we could best hire to kind of extend our research activity, instructional offerings in those spaces. A little more data just to show you where this puts us. So this is, I find this interesting, but maybe I've been in administration too long. So this is a plot of faculty counts at what are called Big 10 plus universities, which includes all the Big 10 universities and a few others like Texas, MIT, Carnegie Mellon, Stanford, and so on. We collectively work together, and the chairs from the different departments share their data every year. So it kind of gives us a perspective on where we're at relative to who we consider our peers for Big 10 ME departments, right? So basically, we are on the far right, and up in 21, 22, we had a little over 30 faculty. So that made us comparable to the size of Rutgers, Nebraska, and we're bigger than Iowa, I guess, in the Big 10, right? And we're way behind some of our peers who have much larger faculties from mechanical engineering departments. With the move of EMA and the recent hiring, where you're getting close to 50 faculty, that makes us close to where Ohio State and Illinois are at, okay? And we're a little, I guess, behind yet where Purdue, MIT, Michigan, and Georgia Tech are. But this puts us much closer to the middle of this range of schools, where to this point, we've actually been very much on the small side for an ME department in the Big 10. So we think this is a good thing from the standpoint that from a reputation perspective, size matters, right? It's just have more faculty doing things, attending conferences, giving talks elsewhere. So it helps our reputation, and it also helps the students because it's additional technical offerings that they can take, additional research opportunities that they can get into as well. So that's an extremely positive thing. And the other part of this is our diversity of our faculty is increasing as well. So this is just showing our female faculty. In 2020, we were down to 2 assistant female professors in mechanical engineering, which was not a good place to be nowadays, as we're trying to increase the pool of underrepresented students in engineering. And we've been able to steadily grow this over the last 3 years up to, and this is FTE, that's why you see half people, up to 7 currently. And this includes both tenure track and teaching faculty, professors. All right, and the last topic before we get into question and answer was the COE building updates. The good news here is we are making progress. So we have an architectural firm. They're working on drawings of a new engineering building that would be located where the old CAE building was. So 1410 Engineering Drive, which is a very old building, 80 plus years old, very limited on what we can do in that space, not much potential to update the space. So that would get torn down. The fountain would actually come out, and where the building is going to extend across a lot of the green space and that current 1410 engineering space as well. So the architects are working with us on a new building plan that would have 7 floors total, 6 above, 1 below. It would get us 340,000 total square feet, and 180,000 of that would be usable. We are trying to do this as a public-private partnership. So we're going to aiming to generate $150 million in donations from private donors to support this. And we're requesting $205 million from the state to support this project. The timeline going forward is is supposed to be the #1 priority for campus. And the governor will be releasing their capital budget in March. We fully anticipated they'll be in there. And then the Joint Finance Committee, we expect will approve this in May. And then we'll be able to progress with the plans from there, with construction beginning in 2025 and the building opening in fall of 2028. So that's an exciting development. The real need for this is we have outdated spaces. We have demand for more students than we can currently accommodate in our current space, and to grow, to educate more students and to expand our research enterprise into some of these emerging areas. We need updated space. I will mention that if you want to help, you can sign a petition that would encourage the governor and the legislative leaders to support our new engineering building. And go to engineeringthefuture.wisc.edu to sign that petition to support this. I also include here a link on Vimeo where you can see a video that gives a short perspective on our need for the new building, some of the activities that could take place, and a little music to get you energized and excited about it. And there's a nice picture of Brad and Caroline, who are both on this call as well, and they are very involved in the building planning and helping to raise funds for that. So that I'm sure they're happy to talk to you, any of you who want to know more about the building. So with that, I am going to open this up for questions. Okay. All right.
All right, so we requested some questions if people had any in advance when you registered. I'm Caitlin Scott. I'm the external communications specialist with the department. Our first question is, how is the department preparing the manufacturing engineers of tomorrow?
All right, Frank Pfefferkorn is on the call as associate chair. He works in the manufacturing space. Frank, you want to take that one?
Certainly. We have 2 required manufacturing courses for our undergraduate students. They were recently redesigned significantly. And in those, we cover polymer manufacturing processes, metal manufacturing processes, automation, and some economics, as well as modeling. So sort of those areas are covered in those 2 courses. We also thereby guarantee that the students all get significant hands-on lab experience, both in the team lab with the metal processes and the Polymer Engineering Center with polymer processing. They still do casting, cutting, welding. They get some touch points with all of that. And then are better prepared to use those tools that we have on campus, now also in the UW Makerspace, which is newer, and the old student shop. Sorry, that's what's called the team lab now. What was just the student shop is the team lab. And we have a certificate in manufacturing engineering that undergraduate students can take. That's optional. Mechanical engineering students can take it without adding any time to degree. So within the constraints of our curriculum, they can get that. And that just allows them to emphasize their tech electives and show that in their transcript. There are also a number of tech electives that our students can take. So that's sort of the undergraduate perspective. And then, of course, those tech electives are also graduate courses for graduate students.
Great, thank you, Frank. Our next question is, what is the next critical area and skill requirements?
I'm going to let Mike Zinn, as Associate Chair for Undergraduate Studies.
Yeah, I think that's a great question, and in fact, it's something that we are always thinking about. And I think our move into mechatronics is one element of that. Daryl mentioned the new class that will be rolling out coming this fall with full sort of implementation the following fall. And the emphasis there is on really a lot interdisciplinary sort of systems level type of work, mechanical, electromechanical, electronics, and programming sort of merged into one. I would also say that I think the other element is on the data science side of that a lot of corporations are, of course, leveraging the vast amounts of data that they're acquiring, and that's no longer just the purview of data scientists. It's also something that engineers use on a daily basis. And so we have done a lot of hiring in that area, and we have plans to revisit our I'll call it sort of data science-ish type of undergraduate course, 331, to try to align more with that kind of material. So, and then robotics as well. So I think maybe, it's about software data integration with other engineering disciplines is really where the industry in the world is going, and we're trying to focus in those areas.
Yeah, the only one I would add on top of that would be energy storage and energy systems as well. And our previous chair, Jal Gandhi, just introduced a class last year in sustainable energy systems, where he looks at things from a fundamental thermodynamics heat transfer perspective in terms of what's feasible with the different technologies. And with the new hires that we have coming on in energy storage, those course offerings are going to expand as well.
Great. It's okay. Another question we had submitted in advance was, are there any plans for HVAC focused mechanical engineering courses?
Yeah, Doug Reindell is a faculty member in our department. He introduced an HVAC course last year that he offered as a tech elective. I don't actually recall exactly what the enrollment, but it's something he's trying to grow. So Doug traditionally teaches in engineering professional development. EPD was dissolved a few years ago, so he moved to the ME department. He still teaches for EPD, which is now known as Interpro, but we're increasingly trying to get him to provide more course offerings to our students as well.
Another alumni submitted.
Shoot.
It's okay. Another alumni submitted question we had was, I would like to see the department develop a program developed for the design and improvement of semi-trucks, engines, aerodynamics, and then unfortunately the text box cut him off, but do you have anything to respond to that?
Mike, what do we have in that?
Well, nothing specific. I know that I was just as a sidebar talking to Dave Rothmer the other day, and there's strong interest in trying to resurrect a vehicle dynamics course, which we used to have. And I think there's just general interest in the department of trying to, on the transportation side of things in particular, to have a more holistic view of that field. With the advent of autonomous vehicles in particular, these systems are no longer can be viewed separately. But I'd say it's a whole that we're trying to address at the moment.
Great, thank you. Related to the EMA merger, we had the question, what new programs will the addition of the engineering mechanics faculty add to the ME program?
Kurt Bronkhorst is on here, and I will let Kurt address that question is he's one of the engineering mechanics faculty moving over from engineering physics to mechanical engineering.
Good afternoon, everybody. Thank you, Daryl. I think the most obvious is that the aerospace engineering option will now be part of mechanical engineering. And we do seek to grow that option within a larger department with a greater number of faculty and a greater number of aerospace engineers or fluid mechanicians who couple with the solid mechanicians. Certainly, as we join a larger department with greater number of faculty, there are going to be a greater number of opportunities for collaboration, closer collaboration with our mechanical engineering colleagues. So I think some of the energy systems and manufacturing systems work that is taking place is a natural opportunity for us to grow into.
Thanks, Kurt.
Next question, will engineering mechanics be kept somewhat organizationally separate from the rest of ME, or will there be an attempt to integrate EM into ME?
The answer to that as chair is absolutely integrate. That's where we see the advantages occurring. What we did from an administrative standpoint is Ricardo Bonazza joined our leadership team in the Department of Mechanical Engineering as the associate chair for engineering mechanics. So we have 3 other associate chairs that I introduced previously. So he's working with the leadership team of the department to represent engineering mechanics, both the undergraduate and the graduate programs. But as we move forward, we really want this to be shared responsibility for the engineering mechanics program to be shared with the mechanics faculty that are in the department and others that have interest in teaching classes relevant to students in engineering mechanics. Likewise, the engineering mechanics faculty are going to be teaching classes that have ME students in it. They already do classes like solid mechanics. We have ME students in there. So it will definitely be integrated and shared responsibility for the 2 programs across the faculty of the department.
But maybe just to be clear, that the degree programs will remain separate, and the engineering mechanics degree programs at both the undergraduate and the graduate level will remain separate programs with different requirements. And the integration is just to make those programs stronger so that they can take advantage of the expertise that's been growing into mechanical engineering.
Correct. Yeah.
Thank you. The next question, the engineering physics department email that went out said EMA students would be able to apply for mechanical engineering jobs. How? Online job applications reject EMA majors.
Paul, did you send that out?
I don't remember exactly how we worded it. I think that, what we expect to be true is that the engineering career services can work with different employers to build a different narrative around how engineering mechanics and mechanical engineering are related. We've always been making the point that engineering mechanics alums are going to be great candidates for many mechanical engineering positions. But I think that it allows our career services folks to really have a different conversation with the department, with this program, part of the mechanical engineering department now.
Will graduates of the engineering mechanics program be granted diplomas in engineering mechanics or mechanical engineering?
Their transcript will still say engineering mechanics for the degree program. It's just administered under the Department of Mechanical Engineering.
After the merge, if one wants a certificate of graduation, will it be issued by the mechanical engineering department?
The registrar's office. Yeah, proof of degree is not something that we handle within the department.
Great. Next question is kind of in the research arena. How can alumni working on energy storage solutions like ion air battery reach out to faculty for collaboration?
I think Xiaoping is on here as Associate Chair for Research. And you want to address this one, Xiaoping?
Sure, I think reaching out, you can reach out to Daria or me. We do have faculty recently hired, including Eric Kazia, as well as Jen Picker working on battery storage. We also have faculty in energy system, engine research center, who work on energy storage. We always look forward to opportunity to collaborate with industry, especially with alumni.
Great, and I believe that is all our pre-submitted questions. So I'm going to start pulling from the chat now. Dennis Beekman typed in here, I'm very interested in the ME department providing opportunities for students from Wisconsin. How is ME reaching out to include capable people from Wisconsin in the engineering programs?
So is this educating us ME students or providing graduates to industry located in the state? I don't, maybe you don't know.
Yeah. Dennis, if you're still on there, are you able to clarify that
There
a
he
bit for
is.
us?
He's trying to change it.
Typing an answer, I think.
Ah.
Yeah. Go ahead. Just take.
Let's see. Another one submitted by Susan Palmer today was, I would love to learn about plans to scale student support services like career services, coaching, wellness for this growth, and how we as alumni can assist in student readiness and programming development.
Can I jump in verbally as well? I would love to, as an alumni who's worked a whole bunch of years, support in a tactical thing as well as a financial thing. I think in particular, the other women in this group, maybe some of the underrepresented folks have a lot of life experience we can ideally share with the students and the student services department. I'm curious again how you're going to scale those resources to make sure the students are both great at their academics, but ready for the work world.
Yeah, so the support services that you're mentioning here are managed at the college level, right, to a large extent, and they have scaled up their offices as we have scaled up our student enrollments in the majors as well, because yes, we absolutely need support staff to do a lot of these things, career services, coaching, and wellness. A few years ago, we also hired Rachel Jones over in the college office as well, who particularly specializes in wellness related issues that students have. And these have become much more prevalent since COVID with our students. And I think is much more awareness of that issue, and probably more recognition of the support that's available, both among faculty, particularly among faculty who need to know where these resources are to point them in the right direction, which has often been the challenge, is getting the connections to occur. So I think we're better, but we do need to continue to scale up that staffing to make that happen. In terms of how can you help us, these are staff related positions. I mean, these are kind of in the operational budget domain. I'm sure that individuals who wanted to donate to the College of Engineering to support these activities as a targeted way, we would certainly engage with you in that sort of conversation on how to make that happen.
All right, looks like the next question that was typed in was a request to share more info on ME interns and co-ops in the next town hall, like stats and trends and industries. So we can certainly plan for that in the next town hall, unless you have anything, right off the cuff, Daryl.
Yeah, I don't have the numbers with me right off hand, and I don't, Mike, do you have any numbers offhand in terms of number of co-op students?
No, actually, I'll pretty much no insight into that. I'd be interested in the numbers when you get them.
Okay, okay.
More to come.
Yes, yeah, we'll certainly put that on the to-do list for the next town hall, and happy to share that information with you.
Our next question was, is there any plan to include WEMPEC initiatives or classes into the ME program? This is from an alumnus of UW-Madison BSME who spent most of their career in designing power electronic systems. They thought it seemed like a perfect match.
Absolutely, we would like to, I would say, reestablish our connection with WEMPEC. So for those that have been around the department for a while, you may recall Professor Bob Lorenz, who was a faculty member at WEMPEC, one of the leaders of WEMPEC, and was a full faculty member in the Department of Mechanical Engineering. So at that time, we had an extremely strong connection, and there was crossover between both the research that he was doing and power electronics and educational activities, as he offered some controls classes as well in the department. We actually, in the process of trying to hire someone in that individual, an opportunity came up in mechanical engineering who would participate in WEMPEC and try to reestablish that connection. So those classes in WEMPEC still exist. Our students could take them as tech electives. The thing that we're missing right now is a faculty member who serves as the bridge. We have a couple of faculty that serve as affiliates in WEMPEC, but it's not kind of their core thing. So it's something we're trying to build. Do you have anything to add to that, Mike?
No, other than we do have still informal connections. I mean, I work with some not advise students, sit on committees that are WEMPEC students. ECE's recently revamped 377 or their version of it as a tech elective, so it's more accessible for our students. That's a power electronics course, the sort of the introductory one. And I do think the mechatronics course will build sort of the fundamentals for that area. But I think, as Daryl said, our hope is to try to build up the faculty numbers in that area to reestablish that connection.
Okay. Yeah, this is Lee. I had the question. Is that there are industries out there, and we're talking about power conversion and drives and things like that, where it's very hard to find mechanical engineers who have specialization with power electronics packaging, attaching heat sinks, and it's a multi-physics environment. It's magnetics, it's thermodynamics, it's high shock and vibration, and it could be an opportunity for Madison to establish themselves as a leader in this field, because it's hard to find other universities that have any programs associated with this. A suggestion.
No, it's a great suggestion, Lee, and thanks for bringing that up today. It's certainly something we would like to see, given the strength of WEMPEC and the ECE side. We would like to bring some more expertise from the ME side, and they likewise would like to see that from the ME side as well. And they say the exact same things that you do. Is they're really good on the electrical side, but there are a bunch of mechanical issues that they're not well prepared to handle, that they could use support on.
All right, thank you.
Our next question was, what are the primary challenges of integrating EM into ME? How are you addressing them?
Primary challenges. Okay. I saw Wendy Crone on there. Call her out of the blue to give her. So Wendy's a longtime faculty member of engineering mechanics and now is an experience. And she's actually going to have a foot yet in engineering physics and mechanical engineering. Wendy, you want to address what you see as the challenges?
Sure. I think probably just becoming familiar with the new culture. You know, the ME department, as you are aware, is larger than engineering physics, and understanding how it operates and how we can interact effectively as faculty within that department are things that we're working on. And so it's not an insurmountable challenge. It's just going to take a little bit of time. And our colleagues have been very welcoming in this and helping us to get through that path. I don't see any particular challenges associated specifically with the degree programs that the students are going to face. It should really be a seamless transition for them. And they may in fact see some new faces in the instructional lineup from our ME colleagues that will benefit them in the long run.
All right, great.
Thanks, Wendy.
It looks like the next question we had typed in was sort of already answered in chat, but I'll verbalize it anyway. Kimberly Green mentioned, as an alum, how can I engage my corporate contacts for sponsorship for ME student projects, undergrad and graduate? And so Brad chimed in with the link to connecting to Mike Cheadle.
Okay, great. Yeah, for senior design projects in particular, yeah, well, that would be with Mike Cheadle.
That looks like all I'm seeing for our questions typed into the chat. Anyone else would like to add anything? The floor is open for that.
This is Frank Pfefferkorn, Associate Chair for Graduate Studies. Just, I guess part of that question was also implied sponsorship of graduate student projects. So I'm not quite sure to what extent that was implied, but certainly you can reach out to me, Xiaoping, or Daryl, if that's something you're interested in, or just connect. Go to our website. We're all listed there. You can also go to, if you go to research, our sort of 6 research areas are emphasized, and go in, and we can help you find a faculty member that's maybe doing, the research in the area of interest there. That's one way. If that's what's implied, funding a graduate student to do research that generates new knowledge that's of use to your company or institution. Also, reach out to Brad or Carolyn if it's about, fellowships for graduate students or whatever. So I'm not quite sure what all is implied there, but just wanted to add that.
Thanks, Frank. Okay. No other questions, Caitlin?
Nope.
Okay.
What I'm seeing.
Okay. Well, thank you all for attending this town hall today. As I mentioned at the beginning, we'd love to get your feedback on what you learned that you didn't know about, that you liked hearing about, or what you would like to hear about in future town halls, how this went for you. We're happy to do them if they're valuable to you, and it helps establish your connection with the department and try to find out ways that we can really work together to educate the next bad round of engineers here, the next generation. So thank you again all for attending today, and enjoy the rest of your day. Bye.